Hi everybody. I was going to do a quick demo here on some deep learning with alternative chips. Accelerating your deep learning workflows with non-NVIDIA GPUs. So, um, I put this together just to sort of dispel some misinformation about you can't do deep learning without an NVIDIA chip. That's certainly not the case. The capability's been out there for a couple years. So now what we're going to do today is we've got this computer vision model, the VGG16, which was published in 2014 out of Oxford, and that was involved in the ImageNet competition. So we're going to use this model. Data set we're going to use is just an in-product model, the TF Flowers data set. It's multi-class image classification. I think there's 5 image classes: tulips, sunflowers, dandelions, roses. There's something else in there. I can't remember the 5th one, but we'll encounter it here shortly. The machine we're using is this Elite Mini. UM780XTX. I just bought this a couple weeks ago. It's got an APU. It's this Ryzen 7 7840HS APU, which also has the 780M GPU chipset. Currently, it's set at kind of, base mode, eco mode. I've got it locked out at 50 watts. So, there's some bit of overclocking we could do to probably speed things up a little bit if we wanted to, but this is kind of just out of the box performance. The reason why I chose this machine actually is because it allows for eGPU support, external GPUs via the Oculink M2 connection. I don't have that installed. It's just the 780M out of the box chip, which has the RDNA 3 architecture. So that's the machine, that's the data, that's the model. Now we'll get over to kind of the programming side of things. First things first, you can kind of skip ahead of this if you are familiar with virtual environments, but I thought I'd just give a demo of that too, since some of these things might be new to some people. So first thing we're going to do is create a new virtual environment, call it DML. We've got some helper code here. You can take a snapshot of that if you want. So that's just creating the environment, and then we'll activate it to get it started up. And then I'm just going to do a bunch of imports here, installation of the libraries we're going to need to do our modeling. There's one down here, the DirectML plugin. That's the library that's going to allow us to access the hardware acceleration specifically for non-NVIDIA chips. So NVIDIA has the CUDA programming. This DirectML uses DirectML kind of plugin. So anyway, we're going to install these libraries. I'm probably going to pause this so you don't have to watch it, just installing libraries. So we'll see you soon. All right, sorry about that. I was doing a couple things in the background. I encountered a dependency error here, so we'll resolve that. It's because pip isn't up to date. Sorry, I've got to put the flag in. When I was installing, oh, sorry, I forgot Python. All right. So that's updating pip here. Another thing I've got going on in the background is we're going to leverage a cloud platform, Paperspace. They have cloud GPUs you can use for training. I've spun up a machine here. I have an account with them. Not an endorsement. I'm just using it for the GPU for this exercise. Anyway, they allow you to spin up a cloud server, so we're going to leverage that. So anyway, I'm going to keep installing things, and I'm going to have three environments basically open at the same time. One's going to be the cloud GPU. Oh, sorry, I didn't grab the that web address to put in to my remote server. All right, there we go. So now I'm on, their cloud machine there. Shrink this guy. So we're going to have kind of on the left here the DML or DirectML environment. In the middle we have just the CPU, and here I'll show you that this is all done now. So right now it's just CPU configured on this local machine. And on the right, let's I can put these code blocks here just to demonstrate what this is here. This is just printing the available devices to me in TensorFlow. It says we have, a GPU there with, here's our memory allocated for the RTX 5000. So that's what we're running on the cloud. I'm going to pause this and finish up this install here. I just have this last. I think I just have this. Maybe I have to install the data sets. I think that's when I encountered the error. Anyway, we'll see in a minute. Okay, now so I've got everything installed here, and we're just going to show you here this DML environment we created. And now we have our GPU with, the 16 gigabytes of VRAM that is on the 780M. Anyway, now we're going to go ahead and look at the code here. We've got some library imports, some functions. I'm not using this grayscale function. We can just take that out of there. Some resizing and rescaling. That's a necessity of the VGG16 model. It requires inputs of 224 by 224 in the 3 color channels. So that's what that function's doing. Just a helper function to plot our metrics of the training. And then a compile and train function that we're going to use to execute the training. I have in here to write a H5 file so I can do something later with the file. But anyway, we'll start running that. We have it on all 3 machines here. We got, again, we've got the DML environment on the left, CPU only on the right, and we've got the cloud NVIDIA chip on. I'm sorry, left is DML, the center is we need to select it, the CPU. I'm just going to run the imports so that everything is kind of on the same page here. Module TensorFlow datasets. Oh, I gotta install this. 1 second. I gotta invoke the installation. All right, sorry about that. I accidentally canceled my recording too. So now that we've got everything installed, we've got DML working, we've got the CPU working. I accidentally grabbed a higher version in the center. That's not really going to matter for the purposes of this. But what we're going to do here, let me shrink this over. This is running in the wrong kernel. There we go. Oh, did I forget to install pandas? Sorry about that. Wait, I don't need it. Let's take it out. Where is pandas? It's just unnecessary. I had it for some I do need matplotlib, so I gotta install that. Okay, 1 second, I'll be right back. we'll keep going while that installs. It's just going to be a second here, but we can get going on explaining the code again. Sorry, I've got inconsistent code across the 3 files because I changed it. But anyway, we talked about the useful functions that we're going to do. We'll import those functions, or load those functions rather, and then we'll take a look at the data. So here is, I forget how many, 40 images I took of the data set. All right, now that that's running, we'll get it initialized over here. So you see there's various resolutions and orientations of the flowers. So we'll kind of handle that. What do we got? What? Okay. Boop, boop. That's kind of strange. All right, let's try that. What are we getting? TensorFlow datasets as cannot import bill there. Photo. Wow. Let's try that. Filter temporary directory. See if we remove it manually. Okay, let's try that. Google. All right, get that out of here. Probably going to close the environment. Sure. All right. Sorry. Boom. Sorry about that, guys. Little reset there. We were in DML, right? So we'll do that. Yeah. Let's try that again. All right, little crazy dependency problem there that we sorted out in live. So we'll get everything all loaded on the 3 machines. Should give us the same. Our seed is set at the same, so it should give us the same set of images across the 3. And so this will resize. We had scale to numpy, that was that resize, and adjust the intensity of the images. So that's just going to standardize our data set there. So yep, I don't know that I got these. Oh, they're offset because I don't have the terminal open on this one. Sorry about that. All right. So that's why. There we go. All 3 are set to standardize the images, and then we'll set our batching. And take a batch of 32 in each pass of the training. So, all right, for the model, we're going to get the VGG16. We'll take each layer of that and add it to our new model. That's build a sequential model from scratch. Some of those are not trainable, right? So at the end, we end up with about 9.6 million trainable parameters in the model. We took off the top layers because I think the VGG16 was doing like 1,000 classes or something like that, ImageNet, whatever that is. So we took that top layer off and added our own classifier at the end. So yeah, five class is in that dense layer. So on the left, I've started the training there. You can kind of see across this is the machine, right? So on the DML side, it's, you know, probably on the order of 20 seconds per epoch or so, something like that. Whereas on a CPU only, it's, you know, well over a minute, probably a minute and 20 seconds per epoch. We'll get it here when it clicks over. 31. That's probably because I'm robbing a bit of the resources when we're running this CPU model. So I'm going to start that on the cloud GPU machine. We'll see how quick that one starts to compile. Yeah, so 18 seconds there on the cloud machine. 31, 27. I'm guessing that's going to come down pretty substantially once I wanted to get through a first epoch here, kind of show you the scale difference. But you know, it's looking like it's going to be about a minute and a half, maybe 2 minutes for the CPU only. Coming down pretty considerably on the NVIDIA chip. On the right hand side. All right, now it's well over 2 minutes, right? So I'm just gonna cancel this out. See how our GPU picks up if we gain any speed now that is, resources are freed up there. Close it down. All right, so it looks like we're stabilizing around 20 seconds here after a few passes. So, you know, it is a bit slower than the NVIDIA chip, but, you know, it's on a different time scale still than the CPU. So, you know, not to limit people what they're doing, you know, definitely we can accelerate some of the deep learning on other chipsets, right? So that was the purpose of the video. Anyway, if you want to learn more about DirectML plugin, you know, Microsoft, Intel, AMD, they're all kind of in a consortium working towards this, right, as a competitor to the NVIDIA chips. So that's where you can figure it out with that link there. Anyway, and there's a PyPI tutorial about the library too you can look into. I'm running this on native Linux. You can, you know, run Windows subsystem for Linux. There's some dependencies that you should probably be aware of. I think TensorFlow has to be 2.1 or less, and then the version of Python that supports that, or the earliest version of Python that supports that, is 3.1. So you got to be kind of careful about what versions you're running where. So anyway, that's the demo, and I think this ran about 14 epochs. Yeah, so there, the NVIDIA machine's already done. 2 minutes there. We're up over 4 now. You know, double, but CPU would have been an order of magnitude, 100 minutes or something, right? And just CPU only mode. So anyway, that's the video, and thanks for watching. Bye.